This is a lecture on how to calculate successive approximations in equilibrium problems. Alright, so our problem is this. We've got a value of K at a certain temperature, and there's the reaction. Methanol makes hydrogen gas and carbon monoxide gas. The initial conditions are given, and our job to determine the partial pressure of each gas, that is in atmospheres, once the system comes to equilibrium. So how do we solve it? First thing to do is we have to analyze what we're given. We're given initial amounts and Kp, nothing else. Remember that there's no difference in how you solve this problem whether you are given Kp or Kc. For this problem we are working with Kp. What does it mean when we're given initial amounts and K? It means that we need to have an ice table and that our change values are going to be unknown. We're going to use the x's in the ice table. We've started our ice table, we've put in the initial amounts, but what do we do now? Where do we add or subtract the x's? We don't have enough information. We need more analysis. So the size of K. Is K large or small? Well, it's 10 to the minus 8th, which makes it very small. Does this reaction favor reactants or products? Since K is very small, it favors reactants by a large amount. With our initial amounts, which way is the reaction going to go? We need to calculate Q. This will tell us what to add and what to subtract. So the first thing is to write the equilibrium constant expression. And since we're doing this in pressures, it'll be the pressure of hydrogen gas squared times the pressure of carbon monoxide divided by the pressure of methanol. We have the pressures of the products divided by the pressures of the reactants. Then we calculate Q, and we take the values, the initial values that were given, and we put them in to the expression. And we find that Q is a lot larger than K. Remember, K is 10 to the minus 8th. This is 0.089. Since Q is larger than K, we've got too many products, too much products, and the reaction will go to the left. So we're going to subtract on the right, add on the left. So we put it into the ice table, and there are our initial amounts, 0.48, 0.44, 0.22, and we subtract X on the right. We subtract X from this carbon monoxide. We subtract 2x from the hydrogen, because notice the stoichiometry there, and we add x to the methanol. So there's our expression for K, and we're ready to solve. Well, maybe not. What we have here is a cubic equation, so we need to do something else. And what we're going to do first is create new initial conditions. So what we're going to do is we're going to push the reaction all the way to reactants. Remember, equilibrium will be reached from any starting conditions. So as long as our stoichiometry is right, we can do this. We're going to subtract 0.22 atmospheres from carbon monoxide, subtract 2 times that from the hydrogen, and add that to the methanol, giving us initial values of 0 for products and 0.7 atmospheres for reactants. Our next job is to make an ice table with our new initial conditions. So this is what we just calculated on the last slide. And we're going to add X to the carbon monoxide. We're going to add 2X to the hydrogen because of the stoichiometry. And we're going to subtract X from the methanol. Now, why are we adding on the right and subtracting on the left? We've got zeros on the right. There isn't any hydrogen or carbon monoxide, so therefore we have to add. If we subtract, we'd have negative amounts. Not good. Alright, so there's our E values. And now we're going to write the equation. So you can see the equation at the bottom there. Now what we have to do is simplify. So we've got 4x cubed on the top, divided by 0.7 minus x on the bottom. And what we're going to do to begin is to make that x 0. because we know that because k is so small, x is going to be a lot smaller than 0.7. We solve the equation, we get x is equal to 2.381 times 10 to the minus third. And during our approximation process, we'll go to 4 significant figures. So then we keep reiterating until the value of x doesn't change. So we're going to put the calculated value of x1 back into the equation and solve it. So 4x cubed divided by 0.70 minus that value of x that we calculated before equals 7.7 times 10 to the minus 8, which is the value of k. We find the value of x2, then we do the same thing, find the value of x3, and those two values are the same, so therefore we can say that x is equal to 3 sig figs 2.38 times 10 to the minus third. Finally, and don't forget this step, we have to calculate all the equilibrium partial pressures. So the pressure of hydrogen is equal to 2x, or to 2 sig figs 4.8 times 10 to the minus third atmospheres. The pressure of carbon monoxide is equal to x, 2.4 times 10 to the minus third atmospheres. And the pressure of methanol is 0.7 minus x, or 0.697 atmospheres, about 0.70. Now we can check our work. Do these values that we came up with calculate to k? Notice our equation for k in the upper right hand corner there. 2 times x, we square that value, times x divided by 0.70 minus x, and that's 7.7 times 10 to the minus 8th. Note here that we needed to use enough sig figs. If we'd only used 2 sig figs, for instance 2.4 times 10 to the minus 3rd, it would have given us a value of 8.1 times 10 to the minus 8. It wouldn't have been right on. Alright, so we have done it. Hooray! Go celebrate!